Okay, so today's task is house robber. Let me use this question. So let's assume we have one, two, three, one. Let's say houses. Houses one, two, three, one, and it means that they are circular. Let's say something like this. So if I gonna solve this problem like 1D, one-dimensional, and the say house, all the houses on the one line. There will be the so like if I wanna solve it like within like for the for this kind of case, so I'll have dp of I as max profit from like considering houses at 0, 1, 2, 3, and this is I from from 0 till I, and then dp of I should be equal. So if there are two cases, if the robber robs the last house, or if it chooses to rob the previous one. So like so if the robber robs, so it's gonna be a maximum between two options. The first option gonna be rob the current house, so whatever payoff pay at I, oh, let's say it's gonna be house I, this is H, house I plus um, I cannot consider a previous house because it will call the police in case I robbed the current house. So I'll do this plus whatever we have the max profit from considering houses from 0 to I minus 2 gonna be dp I minus 2. So dp of I and hi plus dpi minus 2, and then here gonna be or if I don't rob the last house, whatever profit I have from considering like houses from 0 to I minus 1. So this is gonna be the formula for calculating the case in the issue in case like max payout, and on every and the result gonna be dp of n minus 1. So what's the problem here if I convert this one line house to a circular house? The problem there is that if I decide to rob the last house in the row, and the max and the first house, that will definitely will call the police, because in a circular kind of allocation, like structure, the last house and the first house, they are neighbors. So in case I apply the same kind of solution for this circular house structure, circular street structure, um, the case where the last and the first houses and neighbors will be considered and kind of as a candidate for robbing, but this should be excluded. So what I wanna do is, how about I consider what gonna be the payout from houses, if I consider houses from 0 to I minus 1 to n minus 1 minus 2 and minus 2, and then because I explicitly skipped the house n minus 1, so like the last house, I need to somehow to include it. And the second iteration, I'll consider houses from 1 to n minus 1. And this automatically will include, like, the first range will include these houses, 1, 2, 3, and I consider like all of them are candidates for robbing, but I explicitly skipped the last house, so I also need to consider it, but in a different like combination. So like in combination like this one, so houses uh, from the second to the last one, and that explicitly will exclude the first one. Uh, yeah, that will exclude the first one, because otherwise this first and last one will be included in the range, in the possible options for robbing, and they might be selected in case, like, say they have like huge money inside. Let's say the first house have 100 and the last house have 100. So the payout, if I consider like, so here rob this, the optimal strategy gonna be the rob this house and goes here, then on this house gonna be the optimal strategy of that house, and the optimal strategy on this one gonna be rob this and rob this, if I consider this one, and the optimal strategy if I expand gonna be rob this and rob this. So in order to like stop considering like first and last one house in a possible range of combinations, I'll explicitly consider like two options. So um, so I'll have this deep, yeah. So the first um, yeah. So this one is the first run, and let's say I wanna have DP1 and I wanna have, say, DP2. Let's say just n, or like also n minus 1, and DP2 I equal the same, but I plus 1. And the result gonna be max dp1 and minus 2 dp2 and minus 1. Let's check it. Mm. Okay, so if the one house, that's a good edge case. If n, if n gonna be like this one, max, so where it falls. So it falls somewhere I minus 2 greater or equal 0. Ah, okay, it falls here. Hmm. N minus 2 greater or equal 0. Then and this otherwise 0. And then n minus 1 greater or equal 0. And then this one otherwise 0. Hmm. Hmm. So initially I should also put dp1 like 0 equal nums 0, something like this, dp1. And -1. Okay, let's create an. And here also n-2. Yeah, and also the same here. It should be the empty set. Okay, in case of like if n equals 1. So we can, instead of like using dp arrays here, I can use dp1 -1 dp1 -2. And the same dp2 -1 into dp2 -2. And saying dp1 and int 0. And then I'll need to save to move forward. So dp um, 1 m2 equals dp1 m1, dp1 m1 equals dp, and then dp2 m2 equals dp1 minus dp2 minus 1, and dp2 minus 1 equals just dp2. And then in the end I need dp max 1, dp2, and I remove this one. Yeah, that's it. There were a couple of I would say errors here and there, so it's generally fail status. But yeah, the idea is pretty cool. How to convert, like how to transition from like 1D array, 1D array, or like one-dimensional problem to like circular dimensional problem. With a caveat that the first and the last houses cannot be considered simultaneously. So we need to have like the first case where like let's say the first case where houses where uh, where houses should be considered like from their first from the zeros to n minus 2, and then the second case when the houses should be considered from the from the first from the second to n minus 1, something like this. Second case from the first to n minus 1. This will help to avoid a situation when house number 0 and house number 1 and minus 1 will be both selected to rob, and this is not a valid case. Okay, so that's it. This was a house robber, yes, second version of this problem. Yeah, and the conditions are pretty like relaxed here. So as I said, dp of I here is what's the maximum profit we can get by considering robbing from houses like 0 to I minus 1. It's like dp to I to actually to I. It's dp of I. Yeah, so that's it.